calculate the mass of carbon dioxide produced in the reaction. So you refer back to that question here. You find that question, let's say carbon dioxide. Carbon dioxide is on the product side. So we are going to calculate the mass of carbon dioxide produced in the reaction. So our balanced equation is already here. So that's the first step. It says balance the equation. So our balanced equation is, now our second step, it says write down the mole ratio based on the balanced equation. Okay, so our mole ratio now will be 2:7 to 4:6. Our third step, find the number of moles of the reactants. So we have the mass that is already been given there, the mass of the reactants, 32 grams and 39 grams of oxygen. These are the two masses of the reactants. So let's calculate the number of moles. Using the formula, number of moles is equals to mass over molar mass. So in that question, they've given you the mass. That's why we're going to use this formula here. If the question is given in such a way that they've given you concentration and volume, you use this formula for. But for now, let's use this formula here. Okay, number of moles of C2H6, mass over molar mass. Our mass is 32 grams. Divided by the molar mass of C2H6 is 30. Okay, so let's divide. 1.066, round it off to 2 decimal place, 1.07 mole. Calculate the number of moles of oxygen, mass over molar mass. Mass of oxygen is 39. Divide by the molar mass of oxygen. Here is 32 grams per mole. Okay, now step number 4. Write down the new mole ratio below the coefficient ratio in step 2. Alright, so before that, we've got to identify our limiting reactant and the excess reactant. Okay, so in our first question here, we have already identified the limiting reactant. So our limiting reactant is oxygen here. Okay, so in our first calculation, you see, we have 1.22 moles. So we are going to use this number of moles for the limiting reactant, which is 1.22. So 1.22, one number of moles here for oxygen. So 1.22. Remember, the limiting reactant determines the amount of product formed. That's why we are using 1.22. So to confirm, to get this 1.22 divided by the coefficient 7 will probably give you approximately 0.17. So that's our, okay, so 1.22 moles is the number of moles based on our limiting reactant, which is oxygen. So the limiting reactant here will determine the rest of the number of moles of the others. If it's 1.22 moles, we are dividing 1.22 divide by 7 gives you 0.17. So that means 1 mole is 0.17. So 0.17 multiplied by the coefficient 2 here gives you 0.34 moles. So that means for this ratio 2 here, it's 0.34. We are still on 0.17. Multiply by the 4 coefficient here gives you the number of moles for carbon dioxide, which is 0.68 is to 0.17 times 6, 1.02 moles. So these are all the new mole ratio based on the coefficients of the balanced equation. Step number 5, answer what the question is asking you about. So our question here is calculate the mass of carbon dioxide produced in the reaction. So we are using mass of carbon dioxide is equals to number of moles times the molar mass of carbon dioxide. So our number of moles for carbon dioxide according to our mole ratio is 0.68 times the molar mass of carbon dioxide. Atomic mass of carbon is 12 plus 16 times 2 gives you 32. So 12 plus 32 gives you 44 grams per mole. Okay, so times 0.68 gives you 29.92 grams. So that is the answer. The mass of carbon dioxide produced in the reaction. So we can also say that is the theoretical mass of carbon dioxide. Theoretical mass talks about the mass on the product side. We would like to calculate our percentage yield. So if I say calculate the percentage yield, calculate the percentage yield of carbon dioxide, we know that percentage yield is always in the red problem. So if you are reading this first question here, it says 28 grams of carbon dioxide are collected at the end of the reaction. So carbon dioxide is on the product side, so that's your actual yield. Now your theoretical yield is the amount of mass that is being calculated, the theory part of it, theoretical. So that's 29.92 grams. So you times by 100%, get the answer. Okay, so 28 times 100 divided by 29.92 gives you 93.58%. So that's your percentage yield. Now, if my question is asking me to calculate the mass of water, if my question is, I say D, calculate the mass of water. Okay, mass of water produced in the reaction. So water is another of your product. So we are still using mass of water, the formula. is equals to number of moles times molar mass. So your number of moles for water, which is this one here, the new number of moles is 1.02, times the molar mass of water is 18. 16 plus 2 gives you 18. 18.36 grams. So that's the mass of water that is being produced.